5 questions about this silver isotope that get progressively harder as you go along. How many protons does this isotope have? 44, 47, 50, or 100 protons? Very simply, the number in the bottom left corner of the isotope notation is the atomic number, otherwise known as the number of protons. So 47 protons is our answer. What about the number of neutrons that this isotope has? Is it 50, 53, 57, or 100 neutrons? The key to finding this answer is mass number, in this case 100. It's the sum of the number of neutrons and protons. And coupled with the fact that we already know how many protons there are, neutrons make up the difference. So therefore there are 53 neutrons. What about the number of electrons? Are there 3, 44, 47, or 50 electrons? Net charge is our ticket to the right answer. Here it's positive 3, meaning that there are 3 more protons than electrons based upon the definition of net charge. So if we have 47 protons, then we must have 3 fewer electrons, so therefore the correct answer is 44 electrons. What percent of this isotope's subatomic particles, its protons, electrons, and neutrons, are composed of electrons? So whenever we do a percent calculation, it's important to understand what percent means in the general sense. Amount of interest divided by the total number times 100%. So in this case, it's the number of electrons divided by the total number of subatomic particles, protons plus electrons plus neutrons, times 100%. And we already figured out how many of each respective subatomic particles we have. 44 electrons, 47 protons, 53 neutrons. Add it all together, put it through your calculator, and we get 31%. So B is our answer. What is the mass of 1 mole of this silver isotope? 100 atomic mass units, 144 atomic mass units, 100 grams, 144 grams. So we're going to get rid of choices that have 144 in them, because as we showed in the previous problem, 144 is the total number of subatomic particles, but that includes electrons. Electrons have negligible mass, so we're not going to count electrons towards the mass. Instead, we're going to look at the mass number. Mass number is the total number of protons and neutrons, the 2 subatomic particles that actually contribute to the mass. And given that there are 47 protons and 53 neutrons, 1 proton and 1 neutron, they each weigh 1 atomic mass unit, then we're going to have 100 AMUs is the mass of a single silver isotope of this particular kind. But the question is, what's the mass of a mole of these isotopes? And it just so happens that 1 mole times 100 AMUs is equal to 100 grams. So the correct answer is C. 100 grams is the mass of 1 mole of these isotopes. Make sure to check out this video on your screen to ensure you understand the difference between formula mass and molar mass as it pertains to protons, molecules, atoms, elements, etc.